In this lecture, we are going to explore the need for exceptions in your C++ programs. The exception mechanism in C++ was designed to bring problems to the surface in your C++ program. And once we know about the problem, we have a choice to handle the problem and not make our program fall into a crash. Here I am going to show you a few examples of conditions that would otherwise cause your program to crash. For example, if you do an integer division by 0, this is going to crash your program. And here is a simple example. We have two variables. One is a, the other is b. And for b, the value is 0. And if we do something like this, it is possible to recover from such a problem through exceptions. And we're going to show you a way we can do this in a little while. Another case where we might get a crash is if we do a downcast of a reference. For example, here we have our animal inheritance hierarchy, and the dog is deriving from animal, but we set up an animal and try to cast this to a dog as a reference. So we're going to take our animal here and try to cast it to a dog. Now, because we have created a base class, we really have no dog information in this object here. If we try to cast this to a dog reference, the cast is going to fail, but because this is a reference, notice that we are not casting to a pointer. We have no way to mean that we're going to get a null pointer if we do this cast. So this is going to silently fail and it is going to crash your program, but we can recover from such a problem using exceptions, and this is going to make our program much safer. Okay, here is a simple example of how you can recover from an integer division by 0. For example, we can have our example here and have a variable to store our result. We're going to test and see if b is equal to 0 because this is what we are dividing by. So if b is 0, we're going to throw an exception, and this is going to be an integer exception. We're going to catch this and we're going to say integer division by 0 detected in our catch block. This is going to avoid the crash we would otherwise experience if we directly divided by 0 as we have here. This is going to make our program much safer again. Okay, another thing I want to bring to your attention is that the type you throw has to match with the type that you are catching. For example, here we are throwing an integer, but notice that we have a catch block which is only going to catch std string exceptions. So this is going to still crash our program because the C++ compiler is going to look for a possible catch block that would catch an ant, and it's not going to find it here. What we have is a catch block that only catches strings here, so this is not going to work. But if we fix our problem and put in another catch block which is going to catch integers, the compiler is going to see that we are throwing an integer. It's going to look at the first catch block. It's going to see that it is catching a string type. So it is going to skip this and it is going to look down below here, and it is going to find a catch block that can possibly catch an integer. And this catch block is going to handle our thrown exception, and our program is going to work as expected. So you should really know this. The type you throw is going to be handled by a catch block that exactly matches the type that you have thrown in your try block. You should really know this. It is also possible to handle exceptions that are not directly thrown in a try block. For example, here we have a simple function which is going to process two parameters, a and b. We're going to test and see if parameter b is equal to 0, and we're going to throw an exception here. Notice that what we throw here is the const char pointer. So we will need a catch block that can process a const char pointer. Here we have a possible try block which calls our function to process parameters. We're going to pass in a 10 and a 0 here, and we're going to catch the exception here, and we're going to catch it and handle it, and our program is not going to crash as a result of the exception that was thrown in this function here. This is something we can do in our C++ programs. Okay, now that you know this, we're going to head over to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is the need for exceptions. We are going to grab our template files and put them in place. This is going to act as our starting point. We're going to open this in Visual Studio Code by dragging and dropping here, and this is going to give us our main CPP file. We're going to crack it open and remove whatever it is we don't need here. And we are going to set up a bunch of examples to show you potential problems that you could really solve with exceptions. And one of those is an integer division by 0. This is going to give you a crash in most modern C++ compilers. So we have a variable here, a, the value is 45. We have a variable b, the value is 0. If we try to divide these two, we're going to get a crash or some kind of really bad problem. Let's try and do this. We're going to pass this through GCC. You're going to see that build finished with warnings, and the warning is going to be division by 0, and that's what we are doing here. Let's ignore this problem and still run our executable, which was generated. You can see that down here. So we are going to bring up a PowerShell window and we're going to run Rooster. And we're going to see that our program is really not going to run to the end. We can go down and really try to prove this. We're going to say stdc out and say done. We should be able to see this message if our program has run all the way to the end, but hopefully we're not going to see this. Let's build again to take into account the message we just put in at line 10. The build is going to finish with warnings, and it is the same warning here. And if we clear and run Rooster, we're going to see that the compiler is going to hit this line here, and it's going to crash. The operating system is going to say, I can't divide with a 0 integer, so this program is crazy. I am going to finish it, and it is not going to run to completion, as we have seen here. But we can solve this problem with exceptions. And I am going to show you a way we can do that in a minute. And before we get there, I am going to show you another example. And that example is going to involve casting down a polymorphic inheritance hierarchy. Here we have a simple class animal which has a virtual function called breathe. We're going to derive from animal and create a dog class. This should be easy for you to understand now that you know about polymorphism that we have learned about in the last chapter. If you have any problem with what we are doing here, please go back and watch that chapter. You're going to know everything we are doing here. So our dog class is going to publicly inherit from animal, and we are going to set up a virtual function which is going to override what we have in our base class. And we're going to set up a run method which is going to say the dog is running. We're going to also put in a simple member variable to make this a little bit different from what we had in the base class. Now, if we try to take an animal object and try to cast it to a dog, we're going to get a crash because we can't really do that. An animal object doesn't really have any dog information in it. And let's try and set up a simple example. Now that we have the class n, we can go down and do something like this. And I am going to comment out what we had before to make sure the focus is fully on our downcast here. We're going to set up an animal object and we're going to try and cast this animal to a dog reference. Now, this is an animal object, and if we try and run this through the debugger, we're going to see that we have no dog information in this animal here. So trying to cast this to a dog reference is going to fail, but because we are casting this to a reference, we really have no way to say that this is some kind of null pointer because we can't have null references. So this is going to silently crash and your program is not going to run to completion. Let's show you this. We're going to say stdc out and we're going to say done here. If our program run to completion, we should see this message here, but we're not going to see that. We're going to build with GCC. The build is going to be good, so our compilation has no problem. But if we run the program, we're going to see, terminate code, because trying to do something like this is going to throw some kind of exception behind the scenes. And this is going to cause for our program to crash because this is an unhandled exception in our program here. And again, we can solve this using exceptions. And we're going to see how we can do this later in the chapter when we know about standard exceptions. But for now, know that we can really solve these kinds of problems with exceptions. So let's comment this out because we still have a few things I need you to see. What I am going to show you is that we can solve the integer division problem here using exceptions. So we are going to go down here and say our example. Let's make sure this is working properly. Why is this green? We have a comment here, so let's remove this. And here is a simple reminder that exceptions allow us to recover from these kinds of problems we just saw here. Integer division, downcasting from an inheritance hierarchy. We're going to be able to recover from these problems using exceptions. And here we have a simple example. Again, we have our A and B variables. We have a result variable. We're going to put our code, which might do integer division in our try block. And if what we divide with happens to be 0, we're going to throw an exception, which is going to be an integer. We're going to catch it down here, and we are going to handle it. We can take out the string thing here because we don't really need it. I just want you to see that we can catch this directly and do some processing. For example, we can say something went wrong, and we're going to say whatever exception variable we get from our try block, we're going to put it out here. And our program is going to run to completion. If we run this, we're going to see that because B is 0, we're going to throw this exception. The code execution is going to freeze at this line in our try block. We're going to hit our catch block, and we're going to print this message here. And our code is going to run all the way to the end, and we're going to print the end message here. Let's try and build this. We're going to see that it is going to build just fine. And we still have this warning here because we are dividing by 0. But if we ignore the warning and still run our program, we're going to see that it is no longer going to crash. We are going to say that something went wrong, and we're going to run all the way to the end. We are able to recover from a division from 0, and our program is not going to crash. Now, one thing you should know is that the type you throw here should match the type you catch in your catch block. For example, here we are throwing an integer, so this is being caught by an integer. But if, for example, we change this to be an std string, we can do something like this. And you're going to see that if we run the program, this catch block is not going to be executed because what we have thrown is an integer, but this catch block is catching std string exceptions. So this is not going to match what we throw, and our program is going to still crash. We will have an unhandled exception, and the program is not going to run all the way to the end here. Let's build and show you this problem. So the build is finished with warnings. We expect this. Let's clear and run Rooster, and we're going to see that the exception is not going to be handled, and our program is going to crash. We don't see the end message here. So our program didn't run all the way to line 67 here. We can fix this problem by adding another catch block. For example, we can say catch and say int ex to say that this is our exception here. And we can say std cout integer division detected and say that the exception that was thrown is ex here. We can put it out and let's say exception s. We can do something like this if you want. So if we run the program, we're going to see that our integer catch block is going to be activated and handle the error, and we're no longer going to crash our program here. You should really know this. Another thing that this introduces is the possibility to have multiple catch blocks, but we will explore this in detail in later lectures in this chapter here. So let's build and show you that this is going to work. The build is going to finish with warnings. So let's clear and run Rooster. We're going to see that integer division detected. This hopefully proves that this catch block handled the thrown exception here. But the message is that if you want your thrown exceptions to be handled by the catch blocks, the catch block should match the type that you have thrown in your exception here. The last thing I want you to see is that it is possible to handle exceptions that are not directly thrown visibly in your try block. And what I mean by that is that, for example, we can set up a function such as this. This is going to be a function to process the parameters. It is going to process parameter A and parameter B. And we are going to try and do some processing here, but we are going to detect that, for example, parameter B is a 0, and we're going to throw an exception here. If we throw this exception, it is going to be handled by whoever called this function. It is possible to do that, but if you want, you can also put a try and catch block here, but we're not going to do that in this case. So what we are going to do is go down in our code. We're going to comment out whatever we had before, because we don't want this to confuse us in our output. And we are going to put in a piece of code we want to play with. Let's uncomment this to save on time here. And the message is that exceptions thrown out of other parts of code written by you or somebody else. And what we mean here is that this function here may be coming from other parts of your code. It may be written by you, it may be written by somebody on your team, or it may be coming from anywhere. For example, the internet in the library that you have downloaded and used in your program. It may really come from anywhere. But the point is that we can handle exceptions that come from this function here. And if we go to the function, we're going to see that it is going to throw a const car pointer exception. So we need to handle this as such. That's why we put a catch block that is going to handle const car pointer exceptions. And we're going to print it out, and our program is going to run to completion here. Let's put in an end line. We're going to say end or done. You can say whatever you want. And stdendl here. And if we build the program, we're going to see that we're going to throw the exception in the function. And we are going to freeze execution in the function here. And the exception is going to be handled by whoever called this function here. So we're going to hit this line here. The exception is going to be thrown. So we are going to be in our try block here. Once we execute the function, we're going to throw the exception because the second parameter here is a 0. And we are going to hit the catch block and print our message here. And we are going to run our program to completion. Let's build and show you that. We're going to pass this through GCC, our favorite compiler. The build is going to be good. You can clear and run Rooster, and we are going to see our message here, and our program is going to run to completion. So this is something you can do in your programs. This is really all I had to share in this lecture, showing you potential problems that would otherwise crash your programs. But it is a good message we have that we can recover from these problems using exceptions. And it is possible to handle exceptions that are not directly thrown at the level of the try block where we are handling things here. For example, the exception we are handling in this try block is coming from the process parameters function here, and we can handle things in this way. We are going to stop here in this lecture. In the next one, we're going to see that we can handle exceptions at different levels. Go ahead and finish up here and meet me there.